Okay, folks, it's on to 4.7. Well, we start with a basis B, and I'm calling it an ordered basis because if B is a basis is just a bunch of vectors, and the order doesn't really matter per se, but here I want to look at them in a specific order, and you'll see why in a second. The reason is because I want to take a vector x, any vector x, and x is equal to c1 v1 plus c2 v2 plus cn vn, and we already learned that there's a unique scalars that for any given basis there are unique scalars that set it equal to a particular vector. So these scalars c1, c2 through cn are called the coordinates of x relative to b, and that's really what I want to do is define that term. And sometimes you write it this way, that the coordinates of the vector x relative to the matrix to the basis b is these guys right there, and that's kind of written as a vector form. And a very simple example of that would be just using the standard basis. So the vector 3, -1, 2 is 3 times the first vector. That's v1, and -1 times v2, and positive 2 times v3. And I could write it. Oops, I left something out. Through camera magic, that s appears. So the basis of x relative to the basis. You get my point. So the coordinates of the vector x relative to the basis s, which happens to be the standard basis, is this column vector 3, -1, 2.